to the 24 Hours Have Passed Summit preview. We're excited you could join us today for Ike Ellis' session, A Lap Around Azure Big Data and MPP Offerings. This 24 Hours Have Passed event consists of 24 consecutive live webinars delivered by expert speakers from the past community. The sessions will be recorded and posted online after the event. To access any on-demand sessions, please visit 24hourshavepast.com for all session links. My name is Jonathan Stewart, also known as SQLox, and I have a few introductory slides before I hand over the reins to Ike. If you require technical assistance, please type your question into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Please feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I will read your questions aloud to the speaker. You're able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is extremely important to us, so please take a moment to complete it. It will appear in your browser after the session. I'd like to take a moment to thank our presenting sponsors, Quest, Melissa, and Nutanix. The staging of 24 Hours Have Passed would not be possible without their generous support, and they are the reason this event is free of charge. Make sure you explore everything PASS has to offer for data professionals. You can join local user groups around the world, special interest groups, find free online resources through our Learning Center, and read up on the latest community news in the Connected newsletter. Next, I'd like to bring your attention to the upcoming PASS Summit. Taking place in Seattle, Washington from October 31st through November the 3rd, PASS Summit 2017 will feature over 200 sessions with world-class data experts. It's the perfect place to connect, share, and learn from industry experts from around the world, and also to meet a new friend. To find out more, visit passsummit.com. And without further ado, here is Ike presenting A Lap Around Azure Big Data and MPP Offerings. Take it away, Ike.
Thanks, John. So look, guys, I'm a Microsoft Most Valuable Professional, and I write books, and I've got a second edition of my Developing Azure Solutions book coming out in a couple months, but no big deal. Don't worry about that. Let's talk about MPP and big data. So I really have two goals for this session. The first goal is that you look at big data and MPP offerings and see them as easier than you think, so that you will know what to do and how to start doing it. And my second goal is I've looked at a lot of presentations from Microsoft employees. Like if you want to go online from Microsoft and learn about Azure Data Lake, it'll tell you all about Azure Data Lake. But what they don't do a great job of is telling you why you would use Azure Data Lake Analytics versus HDinsight or versus Azure SQL Data Warehouse. And so the purpose of this little hour that we're spending here is to kind of just clarify the world of big data as it stands, show you some vocabulary words, and then so that you understand the language and the lingo and you can better understand documentation when you read it. And then lastly, kind of give you a nudge in the right direction on which products you should probably choose for which problem. So with that, and just to clarify, because I've had bad webinars, you guys can see a data model right now, a star schema. Everybody sees that? Okay, I'm going to go with yes. You can tell me if there's a problem, but this is a typical data warehouse data model, like just using a typical data warehousing method, the star schema. And we've used this for doing analytics and reporting forever. And it's clean and very easy to do reports out of and run cubes out of and run ad hoc queries out of. But the main problem with this is that it requires data movement. This is a typical SSIS ETL workflow. And if you have ever created a data warehouse, you have moved data using SSIS. And you know the pain of doing it. Data movement takes a lot of hardware, particularly network bandwidth. The network bandwidth is precious. It can be saturated and slow, which might mean that we can only do data loads at night or on the weekends. It also might limit how up-to-date our data is. It also has a limited amount of data it can do. Maybe it's good at gigabytes and maybe even terabytes, but we really know as you get into tens of terabytes that ETL becomes very, very painful. moving data is painful. And anybody who's ever moved this piano knows that it always takes a lot longer than expected, and creating the ETL takes longer than expected. So the idea behind a data lake is that lakes don't move, and we don't have to take the cost. We move the data one place, we keep it there in place, and we try not to move it as much as we can. And you'll see that as a theme through all the MPP offerings, is that we try to keep the data where it is without a lot of movement. So how do we get great analytics over dirty data in a central place? The main way we do that is through a NoSQL and Hadoop notion called schema on read. So if the data is dirty where it is, we can define a schema over it and we can clean it through that schema. That schema can also be permanent. So we can use the same schema for ETL or for analytics or for anything that we'd want to do. And you'll see that idea of schema on read when we get to our demos. We can collect all sorts of data. We can collect sensor data and CSVs and log data and then define a schema over it. When you define a schema over it, it's like these rose-colored glasses. The data has a uniform tint that is shareable across all those different processes I've talked about earlier. So now that you know those kind of ideas, I want to define just a simple generic data lake. A data lake is a data architecture term. It is not a product. So in this topic, I'm going to talk about Azure Data Lake Store and Azure Data Lake Analytics as a product, but that's Microsoft co-opting the generic data architecture term data lake. And a data lake is just an enterprise-wide repository for all of your data. It could be CSVs or PDFs or structured data. Structured data is like relational data that you would store in a SQL server. Or it could be unstructured data, which could be like movie files. Or it could be semi-structured data, which would be like CSVs or log files. Typically, data lakes should be cheap. They should be affordable. So if we know we're going to be storing a ton of data, we want it in a place that won't cost an arm and a leg because we can't afford it. James Dixon, who coined the term data lake, said if you think of a data mart, you know that schema I showed you earlier, as a store of bottled water, cleansed, packaged, and structured for easy consumption. The data lake is a large body of water in a more natural state. The next term I want to define is MPP. That's the title of this session, which is a lap around our MPP offerings. MPP stands for Massively Parallel Processing. Processing of a program by multiple processors that work on different parts of a program, with each processor using its own operating system and memory. So what that means is it's taking a big script and dividing it up among multiple servers, and you'll see a slide that shows that in just 1 second. Here's the next vocabulary term, and that's called a Lambda Architecture. And a Lambda Architecture is really a way of doing analytics and data curation when you have a massive amount of data and you'll need an MPP solution. And so I got this slide from Melissa Coates. She was kind enough to lend this to me. And basically you're seeing two paths. On the top where you see devices and sensors, this is like our fast lane. This is if, let's say that I am the CEO of a small airline and I need to know when a flight gets grounded. So all the flight data comes in from devices and sensors, and I ingest it, and I have a little processor, and then I go to a dashboard and Power BI or Excel or maybe just an alerting engine that says, oh, a flight got grounded, you need to do something, right? We're not going to talk about that in this session, but this lower layer, this batch layer, is what we're going to talk about. And what this is we don't need the alerting, but we have a massive amount of data coming in, whether it's log data or sensor data or data from third parties, and we need to store it. And so we're going to store the raw data into the data lake, and maybe that comes out of our speed layer. And then once it's in the data lake, we need to run processes that curate it and load data warehouses with it. And then once we have the clean data in the data warehouse, we can use advanced analytics and machine learning to either report directly off the data lake or out of the data warehouse. So what I'm telling you is some of these products that I'm about to show you, you can use both at the same time if you'd like. But this is very popular, and this is kind of how the the products go. So you're seeing Hadoop, that's the yellow elephant, and we'll explain what Hadoop is in just a second. You're seeing Azure Data Lake Analytics in the process data, that's here, right next to Hadoop. We can also store data separately, and we'll talk about that in just a second, using Azure Blob Storage or Azure Data Lake Store. And then we'll use Azure Data Lake Analytics or Hadoop or SQL Data Warehouse to process data. And then we can use Power BI or Excel or machine learning or even analysis services cubes to present the data for strong analysis and for visualization, dashboarding, and reporting. These are all Azure offerings except for Excel that we can use. So with that, what does Hadoop do? You might not know that, so let me take 3 seconds and just talk about what Hadoop does. Imagine you have a script and you want to divide that script up on 3 separate servers. So you say this first section goes to the top one, and then this middle section, this bottom section. And so it's a lot of data to process, and that's why you're dividing it up across these 3 different nodes. And that's great. That'll work great. You can do that right now even without Hadoop. You can write that by hand in C# or Java or whatever you want to write it in. But sometimes there's problems, like what happens if a server fails? Or what happens if a server isn't performing very well? Or what happens if we just need to get deeper insight into alerting, like maybe something's going to fail later? That means that you're going to build a lot of plumbing into the script. And when you do that, that's just going to, those job retries, alerting, tuning, logging, that's just going to make the script bigger and bigger and bigger and bigger. And as that script grows, it's going to be unwieldy, and you're going to hate writing all that code. So what Hadoop is a reusable framework that takes that job retry, alerting, tuning, logging, security. It's just written for you, and you would just use Hadoop as the framework. So the reason why I'm emphasizing Hadoop is forever, Hadoop has been the main mechanism for building data lakes. And it is the main mechanism in Azure for building data lakes. So as we talk about Azure Data Lake Analytics, Azure Data Lake Store, and HDinsight as separate products, which we're about to do in a second, know that we're following Hadoop design patterns, and we're using Hadoop itself as a product. So with a generic data lake, we really need to separate our needs into 2 things. We decide where we're going to store data, and we decide where we're going to process data. So real quick, let's just talk about the storing of data. So the first place we can store data is Azure Blob Storage. And so if we come all the way back here to this slide, remember this slide where we talked about data lake as this blue part? That we're talking about only the storage of the data, not the processing of the data. So we can choose to store data in one of 2 places really, and that's Azure Blob Storage, or it's Azure Data Lake Store, which are 2 separate products. So Azure Blob Storage is a competitor to Amazon S3. And if we were going to draw up Amazon's version of a data lake, guess what would be center for storage on the AWS side? It would be S3. But since this is Azure, it's Blob Storage that's the center. And what is Blob Storage? Well, it's a place where we can store files like CSVs and JPEGs and docs and PDFs. It's massively scalable. You can store a ton of data in there, and you'll get around 100 millisecond latency. So very, very quick. What's interesting about Azure Blob Storage is that it exposes the data through a web HDFS API. HDFS stands for Hadoop Distributed File System. That API is important because any data you load into Blob Storage will be available to any Hadoop service, even if that Hadoop service is on-prem, or even if that Hadoop service is in a different cloud vendor. So it just has a URI, just a web address, that exposes the data under there, and it follows the rules of the API so that you can use all kinds of different Hadoop products over Azure Blob Storage. Now, a lot of you might have used Azure Blob Storage for other reasons. You might have used it for holding VHDs or for backing up SQL to the cloud or whatever, but I'm telling you, it can be used as the storage location for Hadoop. The second thing you can choose is Azure Data Lake Store, which is also HDFS for the cloud. It's a separate product unrelated to Azure Blob Storage, and you can use the Hadoop files over ADLS, like Spark and Storm and Flume and Scoop and Kafka and Hive and Popcorn and Hillbilly, well, those last two aren't really real. I just made them up, but you would know because Hadoop is just changing all the time. There's new products coming out for it all the time. So those two stores, why would you choose ADLS over blob storage? Well, the main reason you would, two main reasons actually, is that blob storage is really good for a lot of small files, but it's not really good for one single large file. So if you have a petabyte-sized file, ADLS can take care of that, and blob storage really can't. Also, ADLS, the I/O patterns were meant for parallel activities. So if you're doing a large file batch processing, ADLS will give you better performance, but it is more expensive. So be aware that the pricing isn't exactly the same. It's cheap. They're both cheap, but ADLS is probably about double the price of blob storage. So this slide, you can download with the slides and use anytime you want, but it just basically tells you the difference, but I kind of told you the two main differences behind it. The other difference might be that Azure Blob Storage has hot and cold data, which will save you money, but you'll just be aware of that. ADLS will have that one day. So with that, let me just show you storage really quick. So if I go to my Azure account, boop, 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 boop. Hey, get out of here. I don't know why now my bar wants to stay there. Oh, you know what? I think I do know why. It's just because, okay, that's good. Nope, there we go. Okay, so this is my Azure Management Portal, and this is my dashboard. And here I have, sorry about that, my dog barked. Here I have a blob storage account called Data Ike1. And blob storage accounts can have all sorts of things like tables and files in them, but we're going to look at blobs. And then inside Azure Blob Storage, I have a container called Baseball Stats. And inside Baseball Stats, I have a CSV, just one CSV, that I can download right now if I'd like to, or I can look at it. So this is the CSV here, and this is the URI to that CSV. And if I want to, I can click on it and download it, and you can see the data in this CSV that I've uploaded already to Azure Blob Storage. And this is like the name of the player, and it is the team that they're on, and the league that they're in, the number of games they've played, the number of home runs they have, and like their batting average and on base percentage. If you're in the US, this makes a lot of sense. If you're not in the US, I deeply apologize. So that's actually, let's keep that up because we might use that a little bit later. So if I go back to my container, if I want to upload files here, I can just click this upload button, and I can just pick whatever files I want to pick, and I can load them up into Azure Blob Storage. So it's pretty easy to use. If you want to upload a ton of data into Azure Blob Storage, you would use like AZ copy, or you would use the SDK, which I can show you, but I don't have time. So if we look at Azure Data Lake Store as the second thing that we have, that is, well, I don't see it here in my dashboard. So if I go to All Resources and I look at my Azure Data Lake Store account here, I have something similar. I have Data Explorer also, and I have a folder called Baseball Stats, and I have Baseball CSV here. So you can see that this is like a file system that allows me to navigate this, and because this is HDFS compatible, that Hadoop distributed file system compatible, I can use all the Hadoop tools to navigate this hierarchy as well if I really want to. Okay, so you guys get the idea behind the two places to store data. Now that you know that, let's go back and talk about the very first MPP offering, which is Azure HDinsight. Azure HDinsight is just Hadoop as a platform as a service offering inside Azure, which means you don't really know what version of Linux it's running on. You don't really know how they do virus protection. You don't really control hard drives or anything like that. You just create your HDinsight cluster on the Azure portal, and immediately you have access to Hive and Pig and HBase and Spark and Storm and Kafka and all the different Hadoop technologies that are out there. So that allows you to focus on queries and data and not on all the little nitpicky infrastructure things. You only pay for what you need and use. And if you know Hadoop already, this is a very easy way to use MPP inside Azure. We've got a lot of different Azure Hadoop versions that we can use, and this graphic shows you which products are available to which Hadoop version. In the Hadoop ecosystem, there are 3 main distributions of Hadoop. The major player is Cloudera, the challenger is Hortonworks, and the niche player is MapR. And this is Hortonworks. Hortonworks signed an exclusive partnership with Microsoft, and this is their Hadoop offering as a platform as a service offering. So it's easy for developers because we have all kinds of Hadoop tooling that we can integrate into either Visual Studio or IntelliJ. And with that, let's take a look at HDinsight. So if I want to create an HDinsight cluster, I go to my dashboard and I click New, and I click HDinsight. And there's an HDinsight cluster right here. And I could just, it gives me a little blurb about it, and I can click Create. Now here I would just say, like, test, 24-hour pass, right? And then I pick my subscription and I pick my cluster. Now, before I do that, actually, I want to show you, I don't like the quick create. I think what you want to do is the custom. So if you click custom, you get a few more options. And I want to get all the way down to option 4 so I can show you pricing. So you specify your username, like admin, and I've already got a password saved. And then you specify the resource group you want it in. This allows you to group like products together so they can be used. And I just usually use my default storage west option. And then click next. Uh-oh, cluster type. Oh, this is good. Sorry, I wanted to show you this. So under cluster type, you can choose the main purpose of the cluster. And in my case, I like to use Hadoop. Windows clusters are going to be not supported soon, so stick with Linux clusters. You can choose the version of Hadoop that you want and then click select. And now click next. So once you do that, we can now assign a storage account to, so remember, we separated out. We said we store things in either Blob storage or in Azure Data Lake or Azure Data Lake Store. And then we use HDinsight not for data storage, but for running MPP applications. So it's separate. So we can choose what's our primary storage type. Is it Azure Storage or Data Lake Store? And I'm going to say it's Azure Storage, but I could just as easily use Data Lake Store. And then it says, okay, here's, do you have a default container that you want to use or whatever, and we can click next. And then do we want to load any custom applications onto it? And there's a bunch that are offered, but nope, we'll just keep it. Now when we get to number of worker nodes, at HDinsight creation is when we specify our degree of parallelism, meaning how many nodes we want to use. And by default, we will use 4 nodes. And this will charge us $3.63 per hour, which is pretty expensive. So if I want to change either the number of nodes, so I can go down to 2 nodes if I want, and if I do that, you'll see the price will drop, or maybe even 1 node, you'll see the price will drop. But I can also change the type of node. So for instance, for the head node, I can choose the recommended D13, D14, or D5 optimized versions, right? Or I can view all, and I could do lower versions. So like if I do an A3 instance and click select, now I'm down to $1.16. But so my point is, maybe if you're playing around and you've got some money to play with, go low on your performance so that you don't chew through the money really quickly. With that in mind, I'm actually not going to create this cluster in front of you because it takes a long time and we don't have a long time. But I have created a cluster here already. And that cluster I called HDI Ike Demo. And if I click on that cluster, when you create the cluster and it comes up, you can use this dashboard. And when you click this dashboard button, you log in and you get this Mbari dashboard, which tells you the health of your HDinsight cluster. And obviously there's a lot to this and we don't have time for all of this, but I wanted to show you a Hive script. So if you click on Hive on your Mbari dashboard, under Hive View, you can click Go to View. And this is an interactive way of interacting with Hive that's pretty easy. So I'm going to copy and paste a Hive query here. And what I'm doing is I'm creating an external table called baseball stats that sits over that CSV that you saw in Azure Blob storage, baseball stats at data.ike1.blob.core.windows.net. And what it's doing is Hive is creating a table over it with columns. So each one of those columns in the CSV, it's putting a name to it and a data type to it. Sometimes it's numeric and sometimes it's string, right? Then what it's doing is it is dropping another table that I want if it exists, and then it's creating that table. And that table is called big hitters, and it's saying if the number of home runs in those stats are greater than 20, that's a big hitter. If it's not greater than 20, that's a cold bat. And we do that from baseball stats, and then we just select star from big hitters, and we execute. Now, I don't want to stay here while this thing runs, but know that what I could do once I have the big hitters table is I could pipe it to another file, or I could pipe it directly to an Azure SQL database or a different data warehouse or whatever I want. So this is just one example of taking data in place, putting a schema over it, and cleaning it somehow, and then putting it someplace else. Okay, and that's a basic HDinsight demo. So let's go back to our slides, because now you've seen HDinsight and you get an idea of how it's used. Let's talk about Azure Data Lake Analytics. So Azure Data Lake is the product, and it's divided into two different products. Azure Data Lake Store, which I've showed you already, and Azure Data Lake Analytics, which does the batch processing, very similar to what HDinsight does. We call this a low barrier alternative because Microsoft developers tend to feel more comfortable with Azure Data Lake Analytics than they do with Hadoop. The vast majority of Hadoop work is done in Java, and then now it's changing, and a lot more Hadoop processing is done in Python or in Scala, with a very small amount done in C#. So typically, people in the Hadoop ecosystem are comfortable in Hadoop, and people in the Microsoft ecosystem are not comfortable with it. And so consequently, they tend to gravitate now toward Azure Data Lake Analytics. So it is also built on Apache Yarn, which is a Hadoop MapReduce engine. Yarn stands for Yet Another Resource Negotiator. It's basically the next version of MapReduce. And you would create an ADLS job in a language called USQL. USQL is a combination between SQL as a language, which is the language that you and I all know and love, and C#. And you'll see that in just a second. I will show you this in just one second. So right now, ADLS focuses on batch workloads, which is great. We can use it for batch. The interactive and machine learning and streaming workloads that we talked about when we looked at Lambda architecture on that slide, 10 slides ago, that's coming shortly. So Microsoft is putting a lot of money into Azure Data Lake Analytics, and they are committed to it, and that commitment shows. People are using it. So ADLS jobs are written using USQL. Why do we have USQL? Well, I'm a data professional. I speak at SQL Pass Summit and at SQL Saturdays, and I love data. But I also own a software studio, and we write a lot of code in JavaScript and Python and C#. SQL as a language does something. It auto-parallelizes your queries for you. So when you submit a SQL query to the SQL optimizer, it breaks down that query and it parallelizes it across multiple cores. Now, if you talk to data professionals are often frustrated by that because sometimes it parallelizes it without them knowing it, or sometimes they expect it to parallelize and it doesn't. They get a serial plan. And I understand the frustration, by the way. I know that that's frustrating. But it is also amazing that it does that. It's an absolute work of brilliant engineering that SQL can parallelize your queries for you without you writing, locking, and syncing code like we would have to do in C#. So if you go to a C# developer and you show them what SQL is doing behind the scenes, C# developers are amazed by that. They're like, oh, I wish C# could do that for me. Well, that's what USQL is. So uSQL takes the amazing language maturity and mechanisms of C# and combines it with the data-centered and auto-parallelization of SQL. So it's a brilliant piece of technology. So a typical job in uSQL will read data from a file or a table, and it will transform it in the pipeline, and then it will output it to either a file or a table. So it's mainly used for either ETL work or for data processing. And this is what uSQL looks like. So if you're good at SQL, you might recognize this part 3, right? Select star from orders where this date, here's a where operator with an and, right? You know this, right? But you'll know a few differences. The first difference is, well, what's datetime.now? That's not get date, right? That's C#. What's .add days, -7? That's .net, right? What's int, string, float, .net, right? What if we go here, what's customer.contains? That's .net, right? So we've taken SQL as a language and we've merged it with C#. Now, what you'll see is I'm taking, what's this? Extract, does that look like Hive to you that I just showed you? Go to Azure Blob Storage, find or Azure Data Lake Analytic, or Azure Data Lake Store, find the orders.txt file and put a schema over it and then save it as @orders. Now that you have @orders, select from @orders where the date is in between 2 date ranges in the last 7 days and the customer's Contoso. Now take that @orders and output it as a tab delimited file into Azure Blob Storage again as output.txt. In addition, we can combine all of our C# and we can put it into an assembly that we can reuse. So that's kind of like the CLR, where we can put a bunch of C# into the CLR and use it in SQL Server. We can do the same thing in Azure Data Lake Analytics. So that way, if we have a lot of different batch jobs, they can all use the same C# code without us having to duplicate the code over and over and over again. Azure Data Lake Analytics also has federated queries, which means we can take data from Azure SQL Database or from Azure Blob Storage or from Data Lake Store, and we can combine them and then combine the output for piping it someplace, right? So why would you use one or the other? Well, I'll be honest with you. The real reason you'd use HDinsight is if you knew Hadoop already or you had a strong commitment to learn it. And the real reason why you'd use ADLS is if you were in the Microsoft ecosystem and you already felt that was something you wanted to stick with. The secondary reason why you'd use it is HDinsight charges you for the degree of parallelism when you create the cluster. Honestly, I want you to pay attention. So if you fell asleep or you're checking Facebook, pay attention to this one part, okay? So HDinsight charges you for your degree of parallelism whether or not you're using it. So when you create your HDinsight cluster, you specify how many nodes you want, and that, even if you're not using it, you're paying for those nodes. ADLS charges you for the degree of parallelism by each individual job, and I can show you that right now. So if I go into, oh, not there. If I go into Chrome, I was there already. Uh-oh. Come on, Mac. There we go. And I go into my Azure Management Portal. If I wanted to create an ADLS account, it's really easy. I just say Data Lake, and it says, what do you want? Do you want to create either Data Lake Analytics or Data Lake Store? I can say Data Lake Analytics. It has a create button. And this is much simpler. You just name it, choose your resource group, what your ADLS account is, and your pricing model. And most of the time you're going to choose pay as you go. And then click create. Okay. So I don't want to go through the time to do that, so I created one already. And that's here, ADLS Ike. And I have a bunch of jobs here, so I'm just going to take some job I already ran, like highest average team, and I'm going to duplicate it so you can see it. Okay. So this is the same thing I was doing before with baseball stats, where it's schema on read, schema over that baseball CSV. In this case, baseball CSV is an Azure Data Lake store, not an Azure storage blobs. Then I want to know what the highest home runs were for each team, and I save that as the highest home runs variable. Look at that, convert to int32, that's C#, right? And then once I do that, I take that highest home runs variable and I rejoin it to that original variable of baseball stats so that I can get the player name. I'm kind of getting more detail. That's like using a CTE to get more detail. Look at these equality operators right here. They're double equal sign, just like C#, not like SQL, right? And then I output that result into the highest home runs.csv. Now, if you look up here, you'll see this thing called an AU, or analytic unit. And this is an individual ADLA usequel job. And if I click submit, it will run that job. This AU is my degree of parallelism that I can slide. So for this job, it's 3 cents a minute. And if it takes 1 minute, it's just going to cost me 3 cents. But I can scale that all the way up and get a deeper level of parallelism, like 250 nodes, and now it's $8.33 a minute. So you can play with this to decide, do you need performance or do you need to save money? And you could do it job by job. So maybe for this job, I only use 1 AU, but the next time I run it, I use 10 AUs, or maybe when it's an emergency, I use 10 AUs. You get the idea that every individual job chooses their parallelism and therefore chooses the amount of money that job costs. So if I click submit job here, it submits and it runs through like an optimizer process, right? Where it prepares the script and then queues it up for running and then runs it, and then it shows you the end result. And I know that this job takes about 30 seconds to run. So I don't want to wait here for the results. We'll come back to this, and we'll come back and see the results. But I did want to show you something else cool about ADLA, which was you can do this exact same thing in Visual Studio. And this is the same script that you saw before, right? But what you'll see is I have a ike converter process called, so I wrote something called ike converter as the namespace, and the object is convert stuff, and the static method is get best team. And it says if you pipe in the team name, those team names were all 3 characters, it will tell you what the best team is. And guess what? That script has a code behind file. And if I show that code behind file, this is the ike converter namespace, the convert stuff, and then the static method get best team. And it says if you see SDP there, that means that's the great San Diego Padres, because everybody knows that the San Diego Padres are the best team in baseball, regardless of what the standings say, right? So then I can run it, right? I can come up here and say, hey, please run this script on the ADLA Ike account against whatever database I need. And if I click on my advanced options, it will allow me to specify my degree of parallelism, just like the other screen did that you saw earlier. So I can click submit, and that job will start running. So we come back here, it finished, and if I click on my output, the highest home runs, we can look at that data, and you can see that on the San Diego Padres, Will Myers is our best home run hitter with 28 home runs. So this will get swapped out in the other script when the other script finishes with the great San Diego Padres. But we'd have to wait for that. And I'm not sure we want to, because we still have a lot to talk about. So if we go back to our slides, come on, here we go. Boop. Okay, so we saw batch processing. The last product we're going to talk about is Azure SQL Data Warehouse. Azure SQL Data Warehouse is for structured data, mostly, but it has a feature that allows it to get a handle on semi-structured data. So when you load Azure SQL Data Warehouse with data, you load it just the same way you load Azure SQL Database or your on-premise SQL Server. Azure SQL Data Warehouse is just a SQL Server spread across multiple nodes, like 4 nodes or 3 nodes, however many nodes you need, right? Why are we spreading SQL over multiple nodes? It's because we're sharding the data. Sharding means that we're taking a large data set and we're dividing it up among SQL servers. You know, this part of the data goes to this node, this part of the data goes to this node, this part of the data goes to that node. And rather than writing all of the code to keep that data consistent and in the right place with the right amount of job alerting and troubleshooting tools, Microsoft has just done that for you, so you don't have to do that. So it's important to know that Azure SQL Data Warehouse is not for OLTP environments. It's only for analytics. And one of the things it does to control that is it will only support 32 concurrent queries, and the 33rd query will have to wait. So like I said, it's only for analytics. It's only for either ETL work or for aggregating or for, you know, trying to figure out who your best salesperson is or what day of the week you get the best sales or your best selling products or things like that. So its unit of scale is called the DTU or DWU, Data Warehouse Unit. This DTU we get from like Azure SQL Database. So that is the unit of scale that you choose, and you choose that unit of scale when you create the Azure Data Warehouse cluster. And I'll show you that in just a second. Because this is structured data, because it's relational, it's like SQL Server tables, you want to divide up those tables with partitioning. The way you decide which data goes to which node, you have two different choices of deciding that. The first way is round robin, which is as the data comes in, it just gets evenly distributed across all the nodes, but it's random. That might be good enough for your workload, but chances are you'll probably want to do a hash distributed partition scheme, which says that you need to choose the column that you're going to partition in. Let's say that you do it by customer ID. You might say 1,000 customers go on this node, 1,000 customers go on that node, 1,000 customers go on that node, and all of that customer's sales and all of that customer's you know, phone calls and all of that customer's employees and all of that will go on the same node as the customer. And the reason why you're doing that is because you want to avoid joining across multiple nodes. Why are we avoiding joining across multiple nodes? Because if you remember, all the way back at the beginning of the session, I said the whole point of MPP and data lakes is to avoid data movement. And if you have some data on one node that needs to constantly be joined to data on a different node, you are now moving the data, and you don't want to do that. So it's important when you use Azure SQL Data Warehouse to carefully choose how you're going to distribute the data. And I told you about doing it by customer, but you could also do it by order date. You could say all the orders for March go on this node, and all the orders for April go on this node, and all the orders for May go on this node, right? Or you could do it by business unit or however you want to, but you need to think about it carefully. So if you wanted to use a round robin, you do that when you create the table. So what I'm saying with fact internet sales on the left is please create this table across multiple partitions, multiple nodes in Azure SQL Data Warehouse, and do it round robin. It's that with statement at the bottom that says cluster column store index distribution equals round robin. Or if you look at the one on the right, it says please create fact internet sales and do it based on the hash of the product key. So this is saying all of one product sales will go on one node and all the other products will go on another node. So it's important to know that in Azure SQL Data Warehouse that there are non-supported data types like geometry and numeric and in-varchar and the blob, you know, hierarchy ID. You can't use those data types. Now here's the big thing. You also can't use primary keys or foreign keys. These things affect the MPP nature of Azure SQL Data Warehouse. So even though we have a lot of access to very powerful things like user-defined functions and stored procedures and triggers, or not triggers, don't have triggers yet, but you know, SQL Server Management Studio and things like that, we don't have access to some things, so just be aware of that. Azure SQL Data Warehouse also has this thing called Polybase, And rather than tell you about Polybase, I thought I would show you Polybase. So before I show you Polybase, I just want to show you real quick how to create an Azure SQL Data Warehouse cluster. So you click New, and you say Azure SQL Data Warehouse. Actually, I think you just say SQL Data Warehouse. There it is. It says, oh, you want to create a SQL Data Warehouse? Yep, I do. And it says, okay, you name it, blah, 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 blah. It's real simple, right? We know what these things are already. But this is the number of AUs you use. So look, at 500, it's $7.56 an hour. Or at 100, which if you're playing around with, I suggest you start with, it's $1.51 per hour. Now, this takes about 10 minutes to build, and we don't have 10 minutes. So let me just show you. I have one already. That's called, let me go to my all resources, and it is Ike SQL DW. And it's running right now. And I can, you know, if I want to interact with it, I can just start typing SQL using this query editor right now if I'd like. But I can show you something cooler than that. Also, you can see that my degree of parallelism is 100. So this is very similar to HDinsight in that you specify your degree of parallelism when you create it. And if you don't use it, it doesn't matter. You're still paying for it. But unlike HDinsight, you have a pause button. And in one of life's great miracles, if you click pause, it stops billing you. It only bills you for the storage costs. It doesn't bill you for compute. So that like $3 a minute or $8 a minute or whatever it is can be paused at night or when you're not using it, and you stop paying for it, which can save you quite a bit of money. In addition, I want to show you this is just SSMS. And I'm connected to that Ike SQL DW data warehouse. And what I've done here is I want to show you Polybase. I could show you just using SQL, but I promise you it's super boring. You have create table, you have select, you have group by, you have having, you have max, and you know all the stuff you're used to using, CTEs, and you can use here, and you can use it right here in SSMS. So you know that already, and I'm not going to show it to you. But what I do want to show it to you is something that Azure SQL Data Warehouse can do, that even your on-prem SQL servers can also do, but a lot of people don't know about it, and that's called Polybase. So Polybase is our method of getting semi-structured data from CSVs into Azure SQL Data Warehouse. And those CSVs can be stored where? Well, guess what? Blob storage, just like you're used to. And I think now, yes, now Azure Data Lake Store. So the two places we could store data that we talked about at the beginning of the lecture, you can store data using and read it using SQL Data Warehouse. So what we do is we specify a credential. In this case, this credential has a key, and let me just show you what that is. Do you see how this is called data Ike1? That's my location, and this is the key. If I go back to Blob storage, this data Ike1, my access keys, this is the name of the storage account, and this is the default key of the storage account. This is my mechanism of telling the storage account that I am who I say I am. And so when I come back here, what I'm saying is, please create a scope credential called Azure Storage Credential, and call it user, and this is the key. And then use Azure Storage Credential to gain access to that URI. This URI is my Azure Storage account. And then once I have that, create an external file format that I'm going to use. This is just delimited text with a comma. And now create an external table. Now I'm creating a schema over baseball.csv. And it's using that Azure Storage account with the right credentials in order to give me access to it. Now I've already created that for you, but when this is baseball stats, this external table here, it goes out and it loads baseball stats, and it shows me that right now baseball stats has 1,611 rows to use. Perfect. Now the problem is it's going to go read that out of the file, and that might be slow. So typically you wouldn't read it directly out of the CSV, that schema that we placed over the CSV. Typically what we would do is we would take the original file, and we would load it a different table. So that's what this is doing, is it's saying, please create the baseball stats 2 table, and guess what? Do it round robin, right? You saw this syntax earlier. So read the CSV data, but we're going to partition and distribute it across all of our nodes in Azure SQL Data Warehouse. And so when we do that, just to kind of show you, when I read the original file, it takes about a second. But when I read the distributed file that's already there, it's instant, right? Really quick. And that's only with 1,600 some odd rows, right? You can imagine what it would be if it was 1 billion rows or 10 billion or something like that. And we could do whatever we want with this data. We could use max and min and, you know, all the SQL stuff that you know and love you can use here. And in this case, this is me just playing around doing analytics in SSMS. Now, all of these products are compatible with Power BI. All of these products are compatible with Excel. All of these products can be used with SSIS. So just because you're doing some of your batch processing using whatever product you've chosen, you can use the other products that you're used to using as a Microsoft data professional. Okay, so why would you use one over the other? Well, Azure SQL Data Warehouse, you pay for your parallelism when you create the cluster, even though it can be paused. Azure Data Lake Analytics, you pay as you run the job, and that can be quite a bit cheaper. Also, you would choose Azure SQL Data Warehouse if you had structured data and you knew how you were going to parallelize it. You would use ADLA, if you didn't know how you were going to do that yet, and maybe you wanted to do it many different ways to see how it was going to go. You would use Azure SQL Data Warehouse if you loved SQL as a language. You would use ADLA if you love SQL and .NET and maybe R and Python and other languages too. So that's it. This is me. If you want to get a hold of me, I'm at Ike_Ellis on Twitter, but you can email me. I'm always around. You can even call me if you really want. But I really appreciate your time here today. Thank you for joining me, and please let me know if you have any questions.
Well, Ike, that's we have no questions actually. So.
Oh wow, crazy.
Yeah, that's a good thing. Oh wait, oh there's a question. The slides will be the presentation will be available. Somebody's asking are they available, and
Yep.
she said this great presentation from Rose. Somebody says
Thank
go Padres. So
nice.
got some Padres fans. The presentation will be available at 24hoursofpass.com after the event. So give it a couple of days, and the whole presentation will be available. Will you make the slides available as well?
Yep, they're already up. Yep.
Okay, and the slides are already up, so you can just go download those. Bernardo says great presentation, a lot of good info. So that's what a lot of the questions are. Great presentation. They're thanking you.
Nice. That's really nice. Thank you. I appreciate that. Thanks.
Yep. And so for everybody that's still with us, make sure you stay tuned for our next session, Implementing Advanced Analytics with SQL Server 2017 and Python with Ginger Grant. And that will also be a great session. So please stick around and attend that if you have time. Thank you, and have a good day.
Thanks, guys.